Hey gang, we're gonna do a little discovery right now. And by that we mean some hands-on practice, all right? It's good to practice these skills when it comes to knowing what's the right type of antenna for a scenario or measuring EIRP. So we'll go through and show the problems, freeze your video. Then I'll go through the answers with you and we can kind of check our work, and that way you can get more comfortable with this process. So let's dive right in. First set of questions here. All right, go ahead and freeze your video, and then we'll look at them together. Okay, so first question, what antenna would work best for a point-to-point 26-mile link, 42 kilometers? Would we rather use a 21 dBi dish, a 5.2 dBi omnidirectional, or an 8.1 dBi patch? Remember, the first thing is, are they measured the same? Yes, everything's dBi. No one threw any dipole-based measurements, no dBd listed there. So, okay, everything's in dBi. So really, it's just a question of what's the best type of antenna for a point-to-point 26-mile one. And of course, for that, you're going to want a dish, a parabolic dish. You're going 26 miles, all right? You need a parabolic dish to make that happen. What type of antenna would work best for a large lobby coverage from a wall? Dish, omnidirectional, or patch, same measurements as before. Well, in this configuration, again, we're looking for large lobby coverage, and for that, we're trying to, and again, from a wall. From a wall means that we have a specific direction, so omnidirectional is out, dish is way too strong, must be a patch, right? That's exactly what it's designed for, mounted against a wall, be able to manage a large room. Not crazy large, not Yagi large, but large. And how about number 3? What antenna would work best for coverage of a meeting room from the ceiling? Again, the dish, the omni, or the patch. And in this situation, gang, we're going to want to grab the omnidirectional because, again, we're positioning it from the ceiling in the center of the room. That's exactly what an omnidirectional antenna is designed to do. Remember, we focused on that idea of certain types of omnidirectional antenna that would serve that purpose. All right. Number 4, we have a transmitter that emits 40 milliwatts of power. All right, so that's going to be the access point itself is sending out the 40 milliwatts of power. It's going to go through a cable that adds 3 dB of loss. And then it gets to a Yagi antenna. All right, there's our little Yagi antenna. That is a 13.5 dBi gain. So what's our EIRP? Now you might be thinking, oh, I remember this. It's 40 plus 13.5 minus 3. Wait, hold on a second, gang. Is this a dBm measurement? It's not, it's milliwatts. See what we got to do here? Sometimes you got to convert in order to be able to even answer this question. So let's back this train up a little bit and say, first, let's convert our 40 milliwatts to decibels. Remember the rule of 3 and 10? All right, so again, here's our dBm, here's our milliwatts. So let's get 40 by multiplying values of 2 and 10. 2 times 2 is 4 times 10 is 40. That works for me. So that would mean 3 plus 10 will give us our relative decibels. So that's a value of 16. Okay, so I've got a 16 dBm access point. That sounds like a much more likely measurement anyway. Then minus 3 for the cable loss plus 13.5. So what's going to be our total value there? 6 minus 3 is 13, plus 13.5 will be 26.5 dBm. That's our final value there. Don't believe me? Let's take a look at the pretty pictures. Here we go. All right, so again, dish, patch, omnidirectional, 26.5.